Hello and welcome to this video. Special welcome to those who are new to the channel, and make sure if you are new to the channel then you subscribe to the video and press the bell icon so that you can get notifications about new videos and you can keep learning and you can interact with me and let me know what you think about these videos, and possibly we can discuss what more we can do together. So this is the last video on the built-in functions. So let's quickly get them out of the way. So the first is the static method. Okay. So static method transforms a method into static method, much like Java and C++, which can be called without an instance of a class or on class. So for example, let me comment this out. So for example, suppose we have a class A and we define a static method. It can be used as a static method decorator. So we define a function func. It does not take a self argument like other Python functions because it can be invoked without an object. So I can say that return, or rather simply print, don't return anything, print I am a static method. So you can invoke this like func on class A. Okay, so this should work out. This should work. So we run this python lib 11.py. So it prints static method. So you don't need to create an object of class A and it will work. The next function is str method. It returns str version of the class. It internally invokes underscore str underscore. So it is much like rep function. So you can create an object and you can invoke str on that. It will print I am a str function. So it prints I am str function. So that's, you can print whatever you want about the class and the class will print this. Next is sum. So sum is like max. Okay, so it takes an table as an argument and prints the sum of those arguments. So for example, for 1 to 3 it should print 6. So it prints 6. Now for some use cases there are good alternatives to sum. For example, if you want to concatenate strings, then you should invoke empty string dot join and then you give the sequence. And if you want to add floating point values with extended precision, you should use math.fsum. And if you want to concatenate series of iterables, then you should use itertools.change. So we'll see these methods as we explore more of standard library. For now, if you quickly want to sum a list, you can invoke sum on a list. Now we look at super. Super is something like, suppose you have two classes and you have a method which you override, but you want to call the parents class function, then you call super.sum method. Now if I invoke this sum method on B's object, then it will actually print I am a method of A. This is typically used in the constructor functions a lot, where you call super dot underscore init underscore. So that constructs the base class and you can do your initialization and your magic there, and then you call super on that. So for example, if you see, I'm a method of A is printed. Okay, it returns 5, so 5 is also printed. Let's get this out of the way. So you see, it prints I'm a method of A and then it returns 5, so 5 is also printed. Let's get this out of the way. Type, we have already seen quite a lot of times that it prints the type of the object, and a better way to compare with the types is using isInstance method, which we have already covered. So isInstance is a much more suitable and useful function than the type function itself. Now we have vars. So let's hop on to docs.python.org and we simply see last two functions there. So index of this, we have last two functions here. Tuple we will not discuss now. Tuple we will discuss when we will discuss the sequence type themselves. So we look at vars. So var says that return the dict attribute for a module, class, instance, or any other objects with a dict attribute __ dict _ attribute. Objects such as modules and instances have an updatable _ dict _ attribute. However, other objects may have write restriction to their _ dict _ attribute. For example, classes use a types mapping proxy type to prevent direct dictionary update. So this is a problem. You can't invoke vars on all kinds of objects. For example, pane objects which you create, you can't invoke vars on that because the dict attribute itself is not present. Without an argument, vars acts like locals, which we have studied. Note that locals dictionary is only useful for reads since updates to the local dictionary are ignored. A type error exception is raised if object is specified but it does not have _ dict _ attribute. For example, if the class defines the _ slots _ attribute. Now we look at the last library function, that is zip. So what zip does is it iterates over several iterables in parallel. Let me zoom it a bit. Producing tuples with an item from each one. For example, you call zip on 1 to 3 and sugar, spice, everything nice, and if you print the item by iterating over the iterator returned by zip, then it will print the tuple by combining both that. Okay. So more formal definition of zip is that it returns an iterator of tuples where the ith tuple contain ith element from each of the argument variables. Another way to think of zip is that it turns rows into columns and columns into rows. This is similar to transposing a matrix. Zip is lazy, that is, the elements won't be processed until the table is iterated on. For example, by a for loop or by wrapping in a list. One thing to consider is that tables passed to zip could have different lengths, sometimes by design and sometimes because of a bug in the code that prepared these tables. Python offers 3 different approaches to dealing with this issue. By default, zip stores when the shortest table is exhausted, when ignoring the remaining items in the long tables, cutting off the length of the result to the shortest table. For example, this range function will have 3 values 0, 1, 2, and phi 5 4 form has 4, so it will stop at 3. Now zip is often used in cases where tables are assumed to be of equal length. In such cases, it is recommended to use strict is equal to true. Its output is similar as regular zip. So in this case, when you are sure that the two tables have same length, then you can pass strict is equal to true. But in this case, if the length is not equal, it will raise a value error exception, okay, which you can handle. Shorter tables can be padded with constant values to make their tables have the same length. This is done by iter2's zip longest. So there is a helper function for us to do that. So that the padding will be with a constant value, which possibly you can specify in this. So fill values you can specify, and then it will be filled in the shorter iterable. Edge case is that with a single iterable argument, zip returns an iterator of one tuple. With no arguments, it returns an empty iterator. So with this, we come to the end of zip function, and we have explored all the built-in functions here one by one. And now we will go on and study built-in constants, and then we will follow by built-in types, and we will go through each of them in a fair bit of detail by following the entire documentation. Note that when we touch regular expressions, there will be a lot of videos on regular expression. The reason is it is quite an exhaustive, it's quite a complicated topic. Okay, so we will not only read and go through this, but we will actually understand the meaning of all this, and we will explore that what are different patterns, common patterns, and how we can do that. So we will go beyond the Python's library documentation in that case. So whenever there is a need, I will go out of Python library documentation. Otherwise, we will follow Python's library documentation. So with this, we come to the end of this video. And do not forget to like the video, subscribe to the channel, share the video on social media, and make sure you use the comment box to interact with me. Some of you would be very good programmers. Even if new, you might have new ideas, and we can discuss those and we can learn and grow together. Note that when you subscribe to the channel, like the video, or interact with me, it motivates me to make more such videos. Thanks a lot for watching. Happy programming.